Welcome to Treasure Data's webinar. My name is Kyoto Tamura, and I'm your presenter today. Before I begin, I'd like to thank you for taking the time out of your busy day. Also, all questions will be answered at the very end. If you have any question at any given point in time, please feel free to ask during the webinar by sending them directly to me. Here's today's agenda. First, we will go over Redshift and its common use cases, highlighting its strength. Then, we will cover some of the common challenges with running and using Redshift. We will also present common approaches to these challenges and how they are typically addressed. Finally, we present an alternative approach based on Treasure data and walk through an in-production example. No technical webinar is complete without a demo, so I will demonstrate the Treasure database approach with a live demo using our platform at the end of the webinar. So what is Redshift? Redshift is a cloud data warehousing service that became quite popular over the last few years. As one of the first cloud data warehouses, it has made massively parallel processing databases vastly more accessible. Most of the Redshift use cases fall into two categories. The first use case is migrating away from more traditional data warehouses. Among Treasure Data's customers, I've seen users switch from more expensive on-premises alternative to Redshift. Also, Redshift is a drop-in replacement for many relational databases exploited for analytics, often with complex sharding logic. Another use case is event analytics. Thanks to its performance, it's often used as a last mile of analytics pipeline and serve as an interactive SQL interface for business analysts, product managers, and data scientists. Redshift is a truly path-breaking service. However, like all other software, it has its own set of challenges. Let's go over some of them. One of the challenges that we have seen in the market is loading data. Because Redshift is highly scalable, it often becomes the final destination for event data before they are analyzed and visualized. This is great news for data analysts and product managers. They finally have a database that can hold many months of event data and allow them to ask deeper questions. However, getting data into Redshift is no small feat for event data, which is constantly evolving. Unlike most structured data like point of sale and CRM, event data is highly variable. For example, suppose you have a mobile application. Your mobile developer log event data mainly for debugging, which means their event logs tend to be loosely structured at best. Even if they adopt some level of structured logging, let's say JSON as described on the slide, new fields may appear and existing fields may disappear. When those events happen, meaning like let's say the action field disappears because one developer decides that they no longer need it, there's a cascading effect of breaking data pipelines, resulting in a failed data load into Redshift or suboptimal data load into Redshift. Adding and removing columns or changing the data types is only one aspect of schema management. Another key issue is data layout. Redshift relies on the concept of distribution keys and sort keys to optimize data layout so that queries run blazingly fast. Let me explain how this works with the schematic diagrams. So here I'm communicating three types of attributes. They're all squares, but one has an ID. Another is about pattern, whether it's checkered or solid. And then finally, there's the thing about color. So suppose that your data is laid out like this between two nodes. One node has all patterns and the other node also has all the patterns, right? But suppose you're asking questions, let's say joining by color. Then you would probably want to distribute like this, so that all the data with the same color is co-located in the same node, making joins faster. But then later, product manager or data scientist comes to you and say, hey, I actually want to do it not just by color, but also by pattern. And now you're talking. You probably need to update how you distribute or sort your data. This is much easier said than done in Redshift because you cannot actually change the distribution key after the table is already deployed, which means you probably need to make a new table. And that was just a schematic. As I said before, Redshift is often deployed at scale to handle a lot of data. And as you can see, if you start to have a lot of data and need to shuffle a lot of them around, your problem is that much bigger. But here's some good news. There's been a lot of techniques to address these problems, and I want to go through some of them. The first approach is to bring Redshift offline, add a new column, or change the distribution key, and load the new data. This approach takes best advantage of Redshift's design, but it requires careful operations to keep Redshift online for the end users. And in some cases, some downtime is inevitable. So in this example, you might have a sequence of Python scripts that is loading data from S3 to Redshift. As you change the schema or data layout or cluster size, you would have to redirect, so to speak, the scripts so that they go into the new Redshift instance. This means someone in your organization, possibly you, will need to spend a lot of time managing this infrastructure. Another approach is to take advantage of Redshift's ability to parse the text column as JSON. You would have a catch-all column that stores extra fields, and any new field in event data is thrown into that column. If you want to read those extra fields later, you will rely on the Redshift JSON function to retrieve desired fields. This approach has its own set of issues actually around performance. Serializing and deserializing JSON is slow, not just in Redshift, but in many database systems. Eventually, you will want to pull these fields out of JSON string so that you can actually, for example, key based on that, which means you're back to the first case, where you would have to alter, drop, or add new columns to make sure that the data is there and queryable in a way that makes sense. These two approaches suffice in many situations. That said, it would be great if you could take full advantage of Redshift by not worrying as much about schema management or disk key/sort key optimization. This is where Treasure Data comes in. Treasure Data provides analytics infrastructure as a service. By simplifying the process of collecting, storing, analyzing, and integrating event data, we help data engineers and data scientists to do more analysis and less plumbing. We really believe that moving data to appropriate systems and stakeholders is a big deal. And that's why we invented and open sourced two software, FluentD for streaming data and Embulk for batch data. They're both open source and Apache 2.0 licensed. Okay, now let's go back to the problem at hand. The solution is to have a data lake in front of Redshift. A data lake is a place where any kind of data is pulled before they are refined and loaded into downstream systems. A data lake can be constructed with various storage and data processing components. Some people use S3 for storage and a set of scripts to clean and pre-process data before loading data into Redshift. Others build and manage their own Hadoop clusters. In all cases, the goal is to store all data reliably in one place and process them so that they can be safely loaded into downstream systems like Redshift. Many of Treasure Data's customers use Treasure Data to simplify the process of loading data into Redshift, using Treasure Data as a cloud data lake. In the context of loading data into Redshift, we provide a schema on read, fully managed data lake so that no custom scripting is required as you try to move data from data sources to data warehouse like Redshift. What's more with Treasure Data is that you can query your new data in real time using SQL as the data comes in, without waiting for your scripts to run to load the data into Redshift. Hence, we serve as a simplified data loading mechanism as well as a real-time fallback for Redshift to do ad hoc analysis. So let me start the demo. So let me start first with our Redshift environment. So I'm using this standard SQL client called Wagon to connect to my Redshift cluster that is running on US West 1. So there's a table, and there's a table that says top 1. So if I do select points from top 1, limit 1, I can run this query and get the points out there. So what I'm going to do now is go to Treasure Data, log in, and this is what the login screen looks like. I have a couple of sample databases, and we have this notion of jobs where you can run one or more SQL queries and schedule them to send data to various places. The query results are downloadable with like CSV, JSON, TSV formats, and you can connect to data science tools such as Python or R. So what I'm going to do now is I go to the Queries tab and walk through the query that is going to load the data from one of the tables called Hacker News, which is a minutely snapshot of Hacker News that is being streamed into Treasure Data. And I will export some of the fields using this query into Redshift. So let's look at the edit screen. So a couple of things here. We're in the database called Hacker News, and this is a table that we're going to migrate from Treasure Data to Redshift. And there's time, number of comments, various fields. And for the sake of simplicity, I'm just taking 2 fields out from this table, specifying the range since September 1st. The key here is the result export. So if I look at the edit screen, among many result output systems is the Redshift, where we can also output data to other storage like MySQL and Postgres for relational, MongoDB for NoSQL, and so forth. It's also worth highlighting that you can actually create a custom object in Salesforce using our system. So that's the name of our Redshift cluster, my username, password. Optionally, you can use SSL to send the data. The usual suspect if you're familiar with Redshift. So the database is called Hacker News, and I'm going to create a new table called like a top 2. And there are a couple of ways to stream data from Treasure Data to Redshift. One is appending, which is straightforward. It would add data to it. You can replace the whole table. And you can also truncate, which means it honors the schema of the target Redshift table. And finally, you can also update. So I am going to use the copy command here. Use. And I will save and run. Now it is actually fetching the rows. And running the queries. Here you go. So this is time in Unix timestamp, the number of points that each entry has earned. So if I go to my SQL client, and connect, there's a new database top 2. And so let me see that the data is there by like running a query, select sum points from top 2, which is a new table that I created. And if I hit run, it runs and gives the sum of the points that has been earned during that time frame. So the cool thing here is now you can actually use Treasure Data as a data lake and export data to many data marts, so to speak, that you create using Redshift. This really takes advantage of both systems. We're totally schema on read, which means we can accept really any data and pull them before you actually write the ETL job, so to speak, to publish those results into highly optimized Redshift instances. This means Redshift always stays fast, and you can also accept data from many data sources, effectively decoupling the work of application engineers who produce the data or the third parties that you really don't control how they produce the data, and your data engineering data science teams who are tasked to analyze data as questions arise. So that was the demo. And finally, I want to go through one customer use case. So Matomi Group and Malfox, they've been using our service for quite a while, for the last 2 years. And essentially, we are the the big data processing engine for all of their user event data. And just as a quick intro for MobFox, they are a mobile advertisement platform, and they connect advertisers and publishers through their SDK and platform. And one of the things that they need to do is to have accurate reporting for both publishers and advertisers. So initially, they ran the entire system on a sharded cluster of MySQL. And first, they migrated from that to treasure data to take advantage of our scalability and schema on read. Then they were actually publishing the summarized results into MySQL, which in turn powered their customer dashboard. However, as their business grew, the MySQL-based data mart stopped scaling, and also their customers wanted to ask more ad hoc questions, which meant they needed to have more granular access downstream to treasure data. And this is when they decided to adopt Amazon Redshift to power their customer dashboards. And thanks to our data connector result output to Redshift, which I just demonstrated how to use, they can still get data from many sources without worrying too much about schema, but they can feel secure in the knowledge that by using our data connector, the Redshift can have clean and scalable backend that powers KPI reporting. And we've been very happy that we are able to help them process more than 1 trillion events every month. So that is it for the main portion of the webinar. And if you are interested in exploring treasure data more, our contact info is below. And thank you for your time. And now I'm open to questions.
All right, thanks, Kyoto. Got a couple of questions here. So first one is, how are the tables schema handled when there have been changes between treasure data and Redshift?
Yeah, that is a good question. So there are two ways that treasure data affects the schema on Redshift. First of all, as we just saw, if there's no table corresponding to treasure data's output configuration on the Redshift side, we actually create the table on the Redshift user's behalf. And if there's an existing target table, this is where that option about the insert mode matters. So let me go back to my screen, query, edit. So as I said, if I'm replacing, then it actually creates a new schema and overrides the existing one. But if you're either truncating or appending, it honors the existing target table schema, which means even if I ran a query like select star on treasure data side, if the target table only has 3 columns, it makes sure that only those 3 columns appear on the Redshift side.
All right. So actually, good question here. Put you on the spot. So are there any limitations that people should be aware of between the integration from treasure data to Redshift?
That's a very good question. No tool has no limitations. One limitation is distribution keys. So as I covered before, it is really important that you design your distribution key and sort key appropriately to take full advantage of Redshift's performance. However, on treasure data side, there's nothing that we can do to affect that. And what we do is that we assume that you have set your distribution key correctly and try to distribute the data as evenly as possible. So essentially, regardless of whether you're using treasure data or not, it's very, very important that you think very hard about how to set up distribution key. And sometimes the right approach is to just have another table with a different distribution key so that different query workloads against Redshift can be handled optimally.
Okay, good stuff. And then last question, how many people are using treasure data in Redshift today, or do we even know? And what are a couple use cases if we know them?
Yeah, so the use case is very much the one that I showed with the Matomi Mopfox, meaning that they use us as a cloud data lake before they actually put data into Redshift, where the data is more structured but still lends itself for interactive analysis because it's really fast and scalable. In terms of customers, we have dozens of customers using this integration. And to give you some uh, idea, it actually we built the integration because a lot of our customers were using it this way, just using their own tooling. And we wanted to make it easier for them to work with Redshift.
All right. Well, that kind of wraps up the questions today. We want to thank every one of you who took the time to attend this webinar. We'll be reaching out to you, and we will be making a recording of this webinar available online shortly. Thanks very much. Have a great day.